Hi everyone, today we will be discussing Liskov Substitution Principle. The Liskov Substitution Principle is the third principle of solid and it was introduced by Barbara Liskov. So it states that if a class is a subtype of another class, then it should be able to replace it without breaking the behavior of the program. In other words, if we have written some code, there are functions, there are line of instructions, and there is some class, there is some parent class being used in that code. So tomorrow if we replace the parent class with its one of the subclass, then the program should work completely fine. It should show the same expected behavior that we are expecting for the parent class. To understand it much better, what we can do, we will be taking a look to two common examples, and using those two examples we will be able to understand what are the problems when we are not following Liskov substitution principle and what are the benefits of following it. First common problem is this square and rectangle problem. So let us see what is happening here. So there is a class rectangle, it has got its constructor with width and height as usual, and we have created two methods for setting width and setting height, and we have got a area method which is multiplying the width into height. And now we understood, now we thought that since a square is also a type of rectangle, why not just inherit a rectangle and alter it methods to make it work. So first of all, we thought the constructor should need this one size parameter because both the sides are same, and we are taking this size parameter and we are calling the constructor of the parent class, that is rectangle, with this size comma size. And we are also altering the set width and set height methods of the rectangle by just setting both of the width and height equal to width or height width, whatever is being set. So this is the alteration in behavior. Okay, let's see what's more is there. We have this def process rectangle function, and it takes a rectangle, and whatever a rectangle it takes, it just alters its width and height. Okay, and then it basically set the width to 5 and it set the height to 10. Okay, and then we prints it area, and we are expecting that area should be 50 only because we supplied 5 and 10. Okay, so when we tested this rectangle, we created a rectangle with 2 and 3 as width and height, and obviously for this it will work because the height will be set to 5 and width will be set to 10 in the function, and the output will be 50. But when we will test square in place of rectangle, so whenever we will pass the square in place of rectangle, so we are doing this because square is right now a subtype of rectangle, so it should be able to replace the rectangle. So the code will run, but the problem is that first of all the width will be set to 5. Okay, like this dot set width method will be called, and it will set both the height and width to 5. Then again this set height method will be called with 10, and will set both width and height to 10. Okay, and when dot area function will be called, it will give the area as 100. Okay, that was not the expected behavior with that function. So this is how it is not violating the LSP. Like we are substituting the parent with its one of the subclasses, but it's not working the same way that we have expected. Let us see how we can fix this. To fix this, what we can do, instead of inheriting square from rectangle, we will inherit both of them from shape. So we created this abstract class shape using the ABC abstract base class thing from Python obviously, and we have created this abstract method called area. So all its subclasses need to implement this. So rectangle will inherit this, it will define its constructor which takes the width and height. Okay, and this area has been defined that it will multiply width into height and return it. Okay, similarly this square is also inheriting from shape. It is defining its constructor by taking size, and the area is obviously multiplying size with itself and returning that. Now instead of that process rectangle function, we have this process shape, and it takes a shape. Okay, whatever shape it takes, it just calculates its area, shape dot area, and now we can test both rectangle and square here because both rectangle and square are subtypes of shape. So both could be substituted here. Okay, so whenever we are passing this rectangle thing 5 comma 10, it's working fine, it is giving 50. Whenever we are passing a square with size 5, okay, it is again working 5 into 5 25. Okay, so we can see the code here is different than previous one. Okay, but here now in similar scenario it is following the LSP, and since it is following LSP, there is no scope of bugs. In previous problem, what was happening, in previous example, what was happening, we have created this function process rectangle, so it could take any rectangle, and in our implementation we have made the square as a type of rectangle, so we should be able to pass, we should have been able to pass a square there, but it was not working. So that's why it was violation of LSP, and anyone could go wrong because they will see that square is also a rectangle, just pass it. Okay, it should work. So that was the mistake there. Now let's take a look to the another example, this time bird and penguin problem. So here what I am doing, I have created a bird class, and I thought that since bird flies, let's create a fly method here, and it is returning I can fly. I created a subclass sparrow by inheriting bird, and since I didn't want any more modification or any addition, I just have written pass here. I've created this penguin subclass, which is again inheriting from bird, and I thought that yeah, bird flies, but penguin is also a bird, but it didn't fly. So I kind of missed this thing, like this is special case. Let's just alter this fly method and return I can't fly. Okay, so this looks good at first. So there was one function in my program, make bird fly. So it takes any bird and it calls bird.fly and bird flies. So this is the expected behavior of this function. So when I tested it with a sparrow, okay, when a sparrow was being passed in this function, it was returning I can fly, which was expected behavior because every bird should fly as per this, parent class declaration. So, but someone thought that let's replace sparrow with penguin, which is also a bird, and it should again work the same, but this time it's now not working the same, it is saying returning I can't fly. So this is the unexpected behavior. So this is the violation of LSP because it's not working the way it was expected to work with the parent class. So let us see how we could have avoided this violation of LSP. So instead of just thinking that every bird flies, we could have just thought it in more general term, like there are some birds which also don't fly. So why not just add a move method, and depending whether it flies or runs or because there is one ostrich which doesn't fly, it runs. So why not just put a move method? So I made this abstract method move, which everyone has to implement, and I created this flying bird. It is inheriting from bird and it is implementing this move that I can fly, and then is this class non-flying bird, and it is implementing this move method that I waddle on the ground. Again, it should have been more generic, but right now for this example it's good. Okay, now this class sparrow is inheriting from the flying bird and penguin is inheriting from non-flying bird, and instead of this make bird fly function, I will add this function describe bird, or maybe we could have written it make bird move. Okay, and it is doing what? It is printing bird.move. So since move is defined as abstract method in the bird class itself, every function would have, every subclass would have its own implementation of move. Okay, so when we are testing it with sparrow, it is returning I can fly, and when we are returning testing it with penguin, it is returning I waddle on the ground. But right now it is not doing any unexpected behavior because the parent class said that there will be function called move. Okay, and there was no such expected behavior like move should only return I can fly or I move, like it should return something, but it was like some expected behavior, some specific thing was not expected. So that's why it's not violation of LSP. And thinking of something like this, like not hard coding some specific methods in parent class, but declaring them in their subclasses later, can help us to avoid the violation of LSP. Okay, let's try to understand why LSP matters. So when we violate LSP, functions which were expecting base class will break with when we will give some of its subclass, and it will behave differently as we were expecting. Unexpected side effects may occur, and that may lead to hard to find bugs. So in this square and rectangle problem, we found out that instead of 50, we were now getting 100. So this kind of thing may cause some hard to find bugs, because someone will write the whole program thinking that this will only return 50 because I have tested it with a rectangle class also, and it work with any kind of rectangle. So in future, when this whole program will encounter a square instead of this rectangle thing, so this may cause some kind of unexpected result in the end, and the developer will have a hard time finding the original source of the error, and the code becomes difficult to maintain, as developer will need to have some extra checks for certain subclasses. So it will have to think of, like, for which of the subclasses this expected behavior will get violated, this same expected behavior will not be encountered. So on the basis of the subclass, it will have to add check, like if this class is an instance of this thing, then do this, but if it is not that instance of this thing, then continue to do the usual stuff. So the whole code will become quite complex and difficult to write for the developer also. So let us try to see what are the advantages when we follow LSP. First of all, the subclasses work seamlessly in the place of their parent class. So one can mindlessly put the subclasses without thinking, without even considering all the combination in place of their parent classes, and it will work completely fine. Code becomes predictable, flexible and maintainable, and no unexpected surprises when replacing a parent class with the subclass.